quadratic functions. Take it away.
I think that's me, I'm taking it away.
Yes.
Quadratic functions. We talked about linear versus nonlinear functions. This is a special kind of nonlinear function. Nonlinear. So let's talk about the rules for a quadratic equation. Quadratic equations are when we have equations where our x variable, our input, has a exponent on it that is no greater than 2. So it has an exponent of 2 on the x variable. So in this big graphic organizer here, let's look at some trues and falses here. So for quadratic functions, a function in which the greatest power of the variable is 2, that is true. That means that our x can be squared. Not cubed or taken to the 4th or 5th or 6th or 7th or 8th power, but our x can be squared. The graph of a quadratic function sometimes opens upward. That's true. Because what we'll find with a quadratic function is a quadratic function will look like this, or a quadratic function will look like that. Nonlinear. The graph always opens downward. That's false. It can open either way, up or down. The graph is a straight line. That is patently false. Yeah, so quadratic functions are just taking our function where we would have had, let's say we had y equals x plus 1. Now our quadratic is going to be y equals x squared plus 1. And that will affect the way that it graphs. Let's check an example of this here. So we got our quadratic equation, and this, our quadratic equation, is y equals 2x squared plus 1. And in y equals 2x squared plus 1, we're going to make a function table. That's pretty simple. So what we're going to have is here we're going to have our input. Let's put our function here, 2x squared plus 1, our output, and then let's make the ordered pair. So we have an ordered pair here. Okay? So what are we going to use for this? Well, in general, what we want to do is we want to be able to graph this. And what we want to do is we want to graph somewhere around the origin. So when we graph around the origin, we're going to need points around the origin, which means for our inputs, let's use inputs that go from here to here. So that goes -2, -1, 0, 1, and 2. And that'll make it simple for us to graph because we're right around a spot where we know we're going to have graph paper. You wouldn't want to pick x is 50 because x is 50 is way outside the building. Or -50, -50 is in the pod. So let's use these here, and I'm going to write them in first. -2, -1, 0, 1, and 2. Then I'm going to input them into my function. I like to do all the rules here. Remember, this is our rule for our function. I like to do all the rules at once and then figure out my outputs. So I've got 2 times -2 squared plus 1, 2 times -1 squared plus 1, 2 times 0 squared plus 1, 2 times 1 squared plus 1, and 2 times 2 squared, 2's are wild, plus 1, except for the 1. Let's do the math now. Okay, so I got 2, it's exponent first. -2 squared is positive 4. 4 times 2 is 8. 8 plus 1 is 9. -1 squared is positive 1. Positive 1 times 2 is 2. 2 plus 1 is 3. 0 squared is 0. 0 times 2 is 0. 0 plus 1 is 1. 1 squared is 1 times 2 is 2 plus 1 is 3. 2 squared is 4 times 2 is 8 plus 1 is 9. Let's write our ordered pairs. I've got -2, 9, -1, 3, 0, 1, 1, 3, 2, 9er. All right, let's graph this and see what we got. Take that off there. All right, -2, 9, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. -1, 3, 1, 2, 3, 0, 1, 1, 1, 2, 3. Ah, are you seeing some symmetry here? There's some symmetry involved. 2, 9. 2, 9 must be that one. Now when we connect these, here's how we don't connect them. They don't go like this. Okay? They go in the order that we would see them get to the peak of this. And this is our peak here. So this is going to graph out like that. This is going to, should be a curve here, not a corner. And that is, let me write here, not corner. Bloop. This is a curve at that point. All right, when you see that, that's a parabola. So that's the special nonlinear function that graphs as a parabola or a parabola. And what we'll see is that parabolas can actually graph in all four directions, but for our main purposes, we're just going to talk about a vertical graph, and then let's look at the next one, which will be also vertical, but instead of being upward, it's going to be downward. Let's see the next one. Where's my button pusher thinger? Who's got my clicker? I need the clicker. Sorry about that. So here we go. Our second example here, we've got y equals negative 3x squared. We're going to do the same thing. Let's use our function table to figure out how to graph this. I've got my x. I've got my rule, negative 3x squared. I've got my y. And then I've got my ordered pair. Let's use our same values here. Negative 2, negative 1, 0, 1, 2. And then let's set up a rule. So negative 3 times negative 2 squared. Negative 3 times negative 1 squared. 0 times, no. Negative 3 times 0 squared. Negative 3 times 1 squared. Negative 3 times 2 squared. Negative 2 squared is 4. 4 times negative 3 is negative 12, which gives me negative 2, negative 12. Negative 1 squared is 1. 1 times negative 3 is negative 3, which gives me negative 1, negative 3. 0 squared is 0. 0 times negative 3 is 0, which is going to give me 0 and 0, 0. 1 squared is 1 times negative 3 is negative 3, which is going to give me 1, negative 3. 2 squared is 4. 4 times negative 3 is negative 12. And that gives me 2, negative 12. Let's graph it. I've got negative 2. Oh, look, our graph goes by 2's. So negative 2, negative 12. This is going to look really tight here. 1, negative 3. Negative 1, negative 3. 0, 0. 1, negative 3. And 2, negative 12. All right, let's connect this thinger right here. So we've got this going up, 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 curve, and back out. Let's not forget that this is a curve here. That's a V, not a corner. So then we have a parabola that opens up downward. And if you notice why do you think it opened up downward? Our variable term is negative. As soon as that variable term is negative, we're going to have a parabola that opens up downward. Let's go to the review.
Yay.
Let's check the review here. I've got quadratic functions. We're looking to see if it's linear or not linear. What we know specifically, it is a special nonlinear function. A. Can it curve up or down? The answer is yes. It can curve up with a positive variable term. Let me draw that as actually the... Can I have the eraser? Guys, come on. I need you to not do that.
Sorry.
It can curve up here as a positive variable term, or it can curve downward with a negative variable term. And then what's the maximum exponent we can have on the x? What we know is that it has to be 2. So it's x squared. We're looking for x squared. Now, when you get to see these things in the future, what you might see something is in the format of y equals ax squared plus bx plus c. And there you go. That's the big boy. That's a big high school one there. A big quadratic from high school. So in that situation, you might have an equation that looks like y equals 2x squared plus 7x plus 18. And then you do all sorts of stuff with that. All right, so that's your introduction to quadratic functions. Good luck.